have a gas chromatograph in front of us, which the main principle of any gas chromatograph consists of. So the basic principle is to separate the solution with different molecules on the principle of their size, and well, not only the size, but the size is the main criteria, and also the volatility, the how charged the molecule is, and of course you see the main structure of any gas chromatograph, and usually it consists of a carrier gas. In our case, it's just a plain air, which makes a lot easier to operate in the field or in any lab, even the smallest one. So then we have a flow controller, or in our case it's a pump, which pumps predefined amount of air through the column, through the separation column. Before column, we have an injection port for the sample. Usually the amount of injected solution varies between half and 3 microliters. Then goes the column, probably the most important part of the whole system. Well, not the most, but pretty significant, plays pretty significant role. There are two main types of columns, either capillary or packed columns are used. Capillary, as the name suggests, it's just a tiny tube of various lengths from meter to probably to 100 meters. And the difference with packed columns is that, again, as the name suggests, packed columns are packed with some polymer or some material, adsorptive material, which helps to separate constituents of the injected sample. And on the base of different size and other properties of injected molecules, they all have this different time which they travel through the column, and it has that specific term, retention time. At the end of the column, we have a detector or sensor. There are probably at least a dozen of different ones. In our case, we have a CCD detector, which stands for catalytic combustion detector, and probably the best detection or the main use for this type of detector is volatile hydrocarbons, or flammable volatile hydrocarbons. So on the basis of ignition, catalytic ignition or combustion, the sensor detects the voltage difference or spikes, which are transferred to the computer and recorded as a chromatograph, which you can see. So So here we'll start with an injection port, which stands here for the injection of the sampled liquid material. We're using again different types or different syringes, and they have a different volume, from 1 or even half of microliter up to 100 probably. In this particular case, we have a 10 microliter injection syringe. Next, we have column oven, which of course constitutes of the column, packed column, and in our case it's a high step D column of 3 feet length, and of course the heater inside. Okay. So after injection, which I can demonstrate just for the video, inject it and start here. The separation process starts, and depends on the predefined settings. It will take from a few minutes to probably an hour. So the our sample is then separated in the column here, with a predefined flow and temperature settings, and once they reach the sensor, this CCD, catalytic combustion detector, they will be registered and recorded on the computer machine. Yep. So current display setting shows us the current temperature of the column, of the column oven. So that's the main switch. Well, main setting. In this position of the toggle switch, we can see and set up or adjust some of the settings, such as the flow. We can see the actual flow 10. The setting 10 roughly corresponds to about 20 milliliters per minute, and it is an adjustable setting, which can be tweaked, trimmer right there. So we have total set point and local set point, which are the same. So there is no offsetting of. So after that, we have the temperature section. This button shows us the maximum of the column, which the maximum temperature of the column, which is again can be adjusted with a trim pad right there. For this particular model, it's not recommended to go beyond 180 to 100 centigrade. It's not a professional machine, so some care should be taken. So and the last column, again, it's all about temperature. The most button shows us the actual temperature conditions, which is the same as the main setting on the display. And then we have set point, which is set by again by the software as a starting point as 130 degrees centigrade. And again we have the start button, and have a safety switch there, so we cannot operate. Yes, you'll see it. It will get back to the predefined starting point of 130 degrees centigrade. So once we get the temperature equilibrium, which is 130, in our case, as was predefined in the settings, and after some period of stabilization, you'll see the green light on the start button. Will indicate that we can proceed with our testing or sampling investigation of our mixture. So we have a software by the name of Big Simple, which came with the gas chromatograph. So obviously the main area is dedicated for the graph, for the chromatograph itself, and also, but not from the first look, it doesn't appear as anything complicated or sophisticated, but the settings show us the true force or power of this software, which can integrate in automatic mode and with loaded calibration profiles. It can automatically detect and calculate concentrations or areas for the loaded sample. So in this case, I previously ran calibration for three substances, and there were acetone, ethanol, and hexane. But the mixture, we call it sample testing mixture, had only two of the calibrated molecules. So as a result of this chromatograph, we can see that acetone and hexane were correctly identified by the retention time, and from the area, integrated area, concentration was calculated, which you can see in the results section. I'm sorry, I cannot make it bigger, but so our tested the mixture from the label, or the label said that we had a mixture of N-hexane, acetone, and ether in the proportions as 3:1:1. So and the results are roughly coincide with that label, showing that N-hexane has been detected at the percentage concentration of 67.25%, and acetone as 8.57. So the rest we can presume that the rest would or should equal to ether, However, those 25% should be divided into few, at least two other components, as you can see from two spikes. The main spike should tells us that large portion of those 25% comes from ether, and some unknown, undetected, unspecified molecule was also present at some insignificant concentration or amount. So from this exercise we can conclude that gas chromatographs are powerful, being powerful tools in any lab, and this particular example shows us just one way of using it is verifying concentrations of solutions. Also doing an easy qualitative test for the present constituents, and of course the main is identifying the actual amounts, or quantifying the amounts of constituents or molecules present in the investigated sample. So I think this concludes our presentation.
Good work.
Yeah.
That's excellent. Very good.